These are the frequently asked questions in pre-calculus for section P1. I'm going to start with number 51. And the first thing that I would want to do is eliminate some of the negatives. I don't like working with tons and tons of negatives. So what I would do to get rid of at least a set of those so that it doesn't bother people so much is to just go ahead and flip them, because remember, this is reciprocals. So that means this is now going to be on the top, but with a positive 2. So now we'll have y to the 6th, x to the negative 4th, to the positive 2 power. And this is going to go to the bottom and become a positive 4. And there's a lot of different ways to do this one, but usually if people are making mistakes on this, it's because they lost track of some negatives. Now we're raising a power to a power, which means we're going to multiply. And while I'm at it, I'm going to go ahead and put the x in the first position where it should be, because this is backwards. So negative 4 times 2 will give me x to the negative 8th, and that's because when you raise a power to a power, you multiply. Y to the 6th squared, that's going to be y to the 12th. In my denominator, I'll have x to the negative 12th and y to the 8th. And now finally, this is division. So with division, what we need to do is we need to subtract the exponents. Negative 8 minus a negative 12 will be negative 8 plus 12, which is x to the 4th. And then y to the 12th divided by y to the 8th, again we would subtract, and we get x to the 4th, y to the 4th. And no worrying about absolute value here, because we're not talking about using our radicals in these problems right here. All right, number 52, what we want to do is make one fraction out of this. So we're going to do top times top. And remember that when you multiply similar bases, you add the exponents. And bottom times bottom. And then we can see this is just another division problem. So again, 12 divided by 2 is 6. But 3 minus 4 will give us a negative 1. And 3 minus 7 will give us a negative 4. So what we're going to need to do is take the reciprocal of just those terms, because the 6 actually has a positive 1 for its power. That's going to stay on the top, but the a and the b to the 4th will both need to go to the denominator. Now, if you made a mistake on the problems that involve this table, I looked over this problem and I thought, oh, I bet you I see it right here. You didn't read the directions because this had said in millions of dollars. That means we have some zeros that we need to add. So for number, what was it, 54 was the first one you asked for. That one was about capital outlay. You need to remember that you have 6 zeros that need to go behind this in order to make that into millions. So then that will be 5.7375 times 10 to the, count your decimal places, 3, 6, 9, 10. So 2 times 10 to the 10th, and that would be number 54. Again, you had also asked for number 56. My guess is it was the same thing, because 56 is for the total, but you need to put your zeros on there for millions, so that your counting will work out. So 5.28735, because you want that decimal behind the first non-zero digit, and then do your counting. We have 3, 6, 9, 10, 11 positions. So this would be the answer to number 56. But yeah, overwhelmingly, that would be the most common mistake that is made with that chart, is just not recognizing that it's in millions. Then for 63 and 64, we want to do this without using a calculator. So what we're looking for is things that we see in the common in the numerator and the denominator. And first of all, we've got all kinds of times 10 to the going on here. So what we need to do is just treat this as if it were 10 to the negative 7th times 10 to the 8th divided by 10 to the 9th, and we'll have that portion taken care of. So negative 7 plus 8 would be 10 to the 1st, and then we'd have this 10 to the 9th down below, and that would give us times 10 to the negative eighth, because when we divide, we need to go ahead and subtract. Then we look at just the numbers and we notice, hey, 1.3, that's going to cancel out of both of those. Well, the only other number we have in this is 2.4. So this is 2.4 times 10 to the negative 8. Again, just using our knowledge of the numbers that we have up there as we go through that problem. All right, then the other one you asked for was 64. And in 64, yeah, this one, not quite so much fun with the numbers. We're still doing the same thing with our times tens. So negative 7 plus 6 is negative 1. Over 10 to the 7th, we would subtract the exponents, and negative 1 minus 7 would be negative 8. The problem is 3.7, 4.3, and 2.5. Those, it said we couldn't use a calculator, so we're just going to go ahead and do that multiplication by hand. 3 times 7 is 21, and like I said, unfortunately with this one, there really isn't a quick and fast, easy way to do the division. So then you multiply by 4, and that's going to give us 1591. Doesn't want me to write down there, so let me bring this up. And 2 decimal places. And then we need to take that 1591 and we need to divide that by 2.5. So the first thing you would do is move your decimal place over one position, and then you'd think 25 into 159. That goes in 6 times for 150. Bring down have the 9 that we do the subtraction for, and bring down the 1. 25 will go into 91 3 times because that will be 75. And you do your subtraction and you get 16. And then of course we bring down a 0. Well, 25 goes into 160 6 times, gives us 150, and we have a remainder of 10, and 25 goes into that 4 times. So our decimal, again with the arrow here, would be right there, and we would have 6.364 times, now we bring back that 10 to the negative 8th that we needed up above. So there's our answer to problem number 64.